Hello everyone, good morning and welcome to the physics class. Today is Monday, that is 28th of September. Okay, physics will be studying now. In the previous class, that is on Saturday, we were discussing the two last terms in that chapter, that is current electricity. It was electrical energy. Electric energy, and we had discussed also the electrical power. So there we had two formulas we had derived. First one was the energy. We have got different expression for the energy. The first formula was V into I into T, where V stands for the potential difference, I stands for the current that is flowing through the circuit, and T, time, how long the current is flowing through the circuit. The second expression was in terms of the current and the resistance. By using the Ohm's law we got this formula, and the third expression was in terms of the potential difference and the resistance. Okay, so this was the electrical energy. Then we have also found the formula for the electric power. Electric power was given as V into I. Alright, that was the first electric power. And also we had learned that energy, the power is, electrical power is energy by time. So from here we can also find that energy will be power into time. This formula can be used when we have to find the commercial unit of the electrical energy that is consumed by the electrical appliances. Similarly, we have other formulas also there for the power, that is I squared into R. This is the second formula. And the third formula is you have got V squared by R. So these three formulas we will be using from the electric power, and three formulas we will be using from the electric energy. Then based on that, let us do the numericals. I've got the questions in the phone. Okay, all of you see that in your exercise I've already given you some home assignment from this chapter. This is the last section of this chapter. We have got exercise 8.c. Alright, yes, exercise 8c. Exercise 8c. Then we have got numericals. I will be solving numericals today. It is in page number 212. Look at the first question, question number 1. I will not be writing the question because it is going to take a lot of time. I am going to read the question, then I am going to solve it for you. It's very easy question. An electric bulb of resistance 500 ohm draws a current of 0.4 ampere from the source. Calculate number A, the power of the bulb. You have to find the power of the bulb, and second is you have to find the potential difference at the end. So given the electric bulb is there. Okay, so let us take this to be just a rough sketch of electric bulb, but that is not important. The diagram, what is given, you write down there. Resistance, we know that resistance is given by capital R, and it is given to you 500 ohm. Ohm is the unit used for the resistance, and the current is given by capital I, 0.4 ampere. So these are the two data or the values given to you. Now first answer is you have to find the power. Now which formula will you use for the power? You have just learned there are three formulas. I think the first formula that will be used is V into I. Power is V into I. Please see the formula for the power. Then we have got, you just have to But if you see that here the resistance is given to you, alright? But V is not given, so we have to use the second formula, that is I square into R. Okay, so we will be using the second formula for the power. If you see that I is given to you and the resistance is given to you, so you can just substitute and find the answer. I is 0.4, so multiply 0.4 into 0.4. The resistance is 500. The unit of the power we all know is watt. So after doing this multiplication, for 16 signifies 800, 0 cancels, so it will be 80 watt. So the power will be 80 watt. This is the first question. Now you have to find the second one, that is the potential difference. Potential difference is given by V. So in order to find the potential difference here, which formula will you use? I think you use the formula Ohm's law. V equals to I into R. From the Ohm's law, we know that V is equals to I into R. So because I and R both are given to you, so it is quite simple. I is given to you 0.4 and the resistance is given to you 500 ohm. So therefore the potential difference, 4 5s are 20. I think it will be 200 volt. So this is how you are going to solve the numericals. The simple formula is there. The key here is to remember all the formulas and the unit. See, resistance is given by capital R, the unit is ohm. The current is given by capital I, the unit of the current is ampere, given by capital A. Now similarly, we have another question. Let us solve that question number 2 as well. Almost most of the questions are similar. You don't have anything extra that needs to be done here. Just you have to make use of the formula, that's all. Now let us see question number 2. A current of 2 ampere. A current of 2 ampere is passed through a coil of resistance 75 ohm for 2 minutes. So in the first sentence, 3 things are given to you, so you have to write down that. A current, we know that current is I, which is 2 ampere, capital A, is passed through a coil of the resistance 75 ohm. So resistance is given to you 75 ohm and it is flowing for time 2 minutes. Now you have to calculate 2 things. Number A, how much heat energy is produced. So what is the heat energy produced? So you have to find the formula for the energy, because that itself will be the heat energy. If you remember that heating effect of the current, we have found that I square R into T. So it's quite simple. We can use this formula directly here. We have used that second expression for the energy. This energy is also equivalent to the heat energy. Now current is given to you 2 into 2, 4. Directly I multiplied 75, 2 minutes. This minute needs to be changed into seconds. Therefore answer will come in joule. So if you convert that minute into second, you will get the unit. That is, if you multiply this 4 into 75, 8, you will get around 3600 joule. So this will be the energy. Just multiply it. Okay, it's very, very simple. The key is to remember the formula. Second question is, how much charge is passed through the resistance? Charge is given by Q. So Q, what formula will you use for the charge? You have learned at the beginning of the chapter, the charge is equals to current into time. So I into T. Now current is already given to you 2 and it is flowing for how long? It is flowing for 2 minutes. So time is 2 minutes. That minute needs to be changed into second. So therefore the charge will be 2 2s are 4, 4 6 are 24, 240 coulomb. Coulomb is the unit for the charge, okay, which is given by capital C. So like that you have to go on doing the question. Now let us see the next question, number 4. Most of the questions are all similar here. If you look at question number 4, you will be, first of all, there will be given, okay, an electric bulb is rated 100 watt 250 volt. So there is a bulb, it is written like this. Usually all these whatever appliances which runs with the help of the electricity, that is electrical appliances. If you happen to go to a shop and buy one bulb, in the cover outside the bulb, these things will be labeled there, or it will be written, or it will be marked there. So what does it mean? So that bulb has the capacity to produce the power of 100 watt, and the potential difference that it can take will be 240 volt. Now if you look at the potential difference, the voltage will be standard in our place. It will be around 250 to 240. So that is the standard voltage. All the appliances will be marked, or it will be labeled as. So here, so from this question, what do you understand is power is given to you 100 watt, and the voltage or the potential difference is given to you 240 volt. How much current will the bulb draw if it is connected to, sorry, it is 250, not 240. Please make that correction. It is 250. Yes. How much current will the bulb draw if it is connected to 250? So you have to find the formula for the current. So which formula will you use here? Now this is very, very important, because the application of the formula, okay, knowing the formula is one thing. You have to memorize the formula, but the most important thing comes the application of the formula. So we have just learned that the formula for the power is V into I. Since the power and the voltage is given, so we can find the I. Excuse me. So P is given to you 100, and the potential V is given to you 250. If you cancel this, you will get 10 by 50 point, I think 4 ampere after solving it. Yeah, 0.4 will be your current that is flowing through this bulb. So that much current it can take. If the current is more than that, then there is a chances of bulb being crashed. Now let us do another question, that is question number 8. Okay, so there are about 15 to 16 questions. I am just trying to select the questions which have come in ICSE. This question number 8 is an ICSE question. Most of the questions come from here, and also from the examples which are already solved in the textbook. So let us see question number 8. Please, you have to go through the question, and first of all you have to find out what are the things that is given. So that needs to be written down first. In this case, no need to make the diagram. And electrical appliances, this is question number 8. An electrical appliance having a resistance of 200 ohm. So having a resistance of 200 ohm is operated at 200 voltage. So potential difference is, I think both the resistance and the voltage is same. Yes. Calculate the energy consumed by the appliance in 5 minutes. Time is given to you 5 minutes. You have to find the energy that is consumed in 2 units. One is the SI unit, that is joule, and the second one you have to find in the kilowatt hour, which is the commercial unit of the energy. So first of all, let us find the energy. So when R, V and T is given, which formula will you use? I think there is a third formula, which is V square T by R. So this is the formula for the electrical energy. when these three things are given to you. So here we cannot use the formula for the current I because the current is not mentioned here. Alright. Now you just have to substitute and you get the answer. V is given to you 200. So it will be 200 into 200. Time is given to you 5. So you have to convert it into second because we are finding in joule. The resistance is also 200. So 200, 200 cancel. The energy is given to you now. If you multiply all these three, you will get around 60,000 joule. So this is the first answer. You have to calculate the energy consumed by the appliance in joule. So joule is the SI unit of the energy. Now we have to find in kilowatt hour, that is the commercial unit. So number 2. First of all, the commercial unit of the energy is kilowatt hour. There is a relation between 1 kilowatt hour and joule. So that I think I have discussed already, but still I am going to find it for you. I am going to derive it for you. So 1 kilowatt you change into watt, it becomes 1000. Hour you change into second, it becomes 60 into 60. So it becomes watt. Yes, watt second. Okay, so if you see that 36, 1, 2, 3, 4, 5. So you have got 5 zeros, it becomes joule because watt is joule per second, second cancel. So this is the relation. Okay, 1 kilowatt is equals to 36 into 10 to the power 5, or if you put a point here, it will be 3.6 into add 1 zero, that is 10 to the power 6. So now this joule has to be converted into kWh, that is kilowatt hour. So you just have to divide this 1, 2, 3, 4 by this value. 36 into 10 to the power 5 means 1, 2, 3, 4, 5. So now it has been changed into the commercial unit of the energy, which is kilowatt hour. 1, 2, 3, 4. Cancel, so you will get 6, 1 by 60. I think yes, 1, 2, 3, 4, 1, 2, 3, 4. So after solving this, you will get answer in the decimal point. Please try this. How much will you get? You will get around 0.016 kilowatt hour. So this is, look at this. Both are the energy that we have found in this case. The first one is in joule, that is SI unit of the energy. Second one we have found in the commercial unit, that is kilowatt hour. By converting, so in order to convert the joule into kilowatt hour or the vice versa, this relation you have to know. That means 1 kilowatt hour is equals to 36 into 10 to the power 5 joule. So like that, we have got many questions there. Let me solve 1 or 2 questions for you. Let us do this question number 15. See this, it is in page number 213. Now this is slightly, here we have to use the formula of this EMF of a cell. Last time we were discussing the internal resistance, EMF, the terminal voltage, etc. Let us do that question now, question number 15 in page number 213. Okay. A bulb is connected to a battery of the potential difference 4 volt. Given there is a bulb which is connected to a battery of the potential difference 4 volt and the internal resistance. So internal resistance we have learned last time is 2.5 volt. Okay, the internal resistance is given to you 2.5 volt. a steady current of 0.5 ampere, a steady current 0.5 ampere flows through the circuit. There is a circuit. In that circuit, it is of a cell. In the cell you have got an internal resistance given by small r, and from there a steady current is flowing. And how much is the current? 0.5 ampere. And this is your, let us say, the total that is potential difference, which is the EMF of a cell. Okay, so now you have to find two things: the total energy supplied by the battery in 10 minutes. You have to find the energy. So when you are given V, R, I, so which formula we are going to use for the energy? V, the first formula. This is the total energy supplied by the battery. So what is the total potential difference? 4. And what is the current? 5 by 10. The time, it is flowing in how much time? It is flowing in 10 minutes. So you have to change into 60. That is, you have to change into what do you call? Second. So after cancelling this, 4 5s are 20. 1200, I think, yes, 1200 joule. So this will be your total energy. So this potential difference, you can take it as the total potential difference. All right. Now let us see the second question, the resistance of the bulb. Now you have got the internal resistance, you have to find the external resistance. So the external resistance is, you have to use the Ohm's law. So V, the total, you can write in place of V, also you can write EMF, I into resistance. But resistance, how many are there? External and internal. Okay, there is a, this R is the resistance of the cell, and this is the resistance of the bulb, which is the extra. So if you solve it from here, what is V given to you? 4. The current is 0.5. If you remove the decimal, you will get 14. The internal resistance is 2.5. 8 plus R, 8 equals to R plus 2.5. So if you transpose it, the resistance of the bulb, that is external resistance, will be 8.05.5 ohm. So the external resistance, or the resistance of the bulb, is given to you 5.5 ohm. Now what is the energy? Number 3 you have to calculate is the energy dissipated in the bulb in 10 minutes. So how much energy is consumed by the bulb? So here we are going to use the total only the resistance for the bulb. So number 3, energy dissipated by the bulb, you can use I square R into T. Okay, now either from the bulb or the cell, there is one current flowing. What is the current flowing there? 0.5 into 0.5. What is the resistance of the bulb? We got this now. Only for the bulb, this 2 is the total resistance, but the resistance for the bulb we got is 5.5. And for how long it is flowing? 10 minutes. Please change that minutes into seconds. Now after doing this multiplication, you will find that answer will come as 825 joule. So this will be your energy. Okay, now so there are so many other questions up to 21 is there. So let me do this question 21 quickly. That will be the last question for today. And the rest of the question you can do it yourself. It is quite simple. The key thing is you need to remember the formula and the correct unit for all. So let us see this question number 21 now. A geyser, there is a geyser, that is the electrical appliance, is rated 1500 watt 250 volt. So 1500 watt means the power is, it consumes quite a heavy power, and as I have told you already, the potential difference, the voltage drop will remain uniform around 240 to 250. This geyser is connected in the mains. Calculate the current. So how much current is flowing through that what I call geyser. So to find the current, we have to use power V into I. So it's very easy. P by V. Okay. So what is the power? 1500. The potential difference is 250. You can cancel that 0. After cancelling, how much you got? You will get 6 ampere. Okay. 5 is that? 5 3 is that? Yes. 5 6 is 30. Then number 2. The energy consumed in 50 hours. So if that geyser, suppose this is the geyser, all right. The power is supplied here, the current is flowing into it. If it is kept on for 50 hours, almost 2 days, if it is continuously kept on for 2 days, how much energy it is consumed? So in that case, we have to use the commercial unit. All right, so we have to use the commercial unit, and the commercial unit will be kWh. Okay, so for that, the energy, the formula you have to apply is, what will be the formula? V into I into T. Okay, V into I into T. Now what is the V? 250. The current, how much you got just now here? The current is 6, and the time, it is flowing for 50 hours. So time, you will keep it in hours. But since this will give you in watt, but we know that the commercial unit is kilowatt hour. So when you change the watt, you have to divide by 1000. So then it becomes kilowatt hour. Now you must be asking here, why this 1000 is, why we have to divide by 1000? Because in order to find how much energy is consumed by this geyser, we have to first of all take into account the commercial unit, and the commercial unit is kilowatt hour. Time we have kept hour only, 50 hour. We have not changed into minute or second. But this part, it is in SI unit watt. But when you change watt into kilowatt, you have to divide by 1000. So after doing the division, 5, so I am running out of this ink. Okay, so if you multiply this, it will be 75 kilowatt hour. That means it will consume how many unit? 75 unit. Because 1 kilowatt hour is 1 unit. So if you keep this geyser on for 50 hours and continuously, the current is being supplied, but by the time you keep it on for 50 hours, it will be damaged, it will be destroyed. But suppose that is the assumption. So how much power is consumed by this electric geyser? 75 unit. Now the third question is, what will be the cost of energy consumed at 4.20 paisa per unit? So for 1 unit, the cost is 4.20. So what will be the total cost now? The total cost will be 420, that is 420 is 1 unit, into how many unit you have got? 75. So that much money you will get, 315 rupees you have to pay if you keep it, the geyser on. So this is how you will also get the idea of how to save the electricity in terms of this unit by using less of these appliances. Okay, so now all the numericals we are not able to solve, so I have solved almost more than 50%. The remaining you have to do it yourself, and also practice all the examples given in textbook in page number 209 and 210. So we have come to the end of the chapter. In the next class we will be starting a new chapter, that will be heat. Okay then, see you.